In this video, we'll look at solving equations on number 1, and then we'll also look at number 2. So on number 1, we're solving this equation where we need to isolate the power. The power is just the x to the 4th. So I have to add 5 to both sides first. So adding 5 to 157 would be 162. Okay, dividing both sides by 2 next would give you x to the 4th equals 81. And to do the inverse of x to the 4th, we need to do the 4th root of this side, and then the 4th root of this side. So x equals the 4th root of 81, or in other words, what number to the 4th power is equal to 81, and that is equal to 3. Alright, on part B, we need to isolate the power first, so we need to subtract 19 from both sides, so this would become a negative 27. And then we want to do the inverse of cubed, so we can do cube root of the left side, and then we would have to do the cube root of the right side. So the cubed and the cube root cancel, and we're left with 5th root of 2x minus 7 equals the cube root of negative 27 is negative 3. Then we need to do the inverse of 5th root, which is an exponent of 5, so to the 5th power. Left side, the 5th root and the 5th cancel out, so that gives us 2x minus 7 equals negative 3 to the 5th power is negative 243. Adding 7 to both sides would give us negative 236, and then dividing by 2 would be negative 118. Alright, now on part C, this is a different type of equation. We have an exponential equation where the variable is in the exponent. So in order to solve this, we need to rewrite both sides of this equation with the same base. So 7 squared is 49. 7 to the 3rd is 343. Once both sides are written with the same base, you want to include the original exponent. So 4x, and then on this side, 3x plus 1. The original exponent is in parentheses. So 2 times 4x, this, should be the same as 3 times the quantity 3x plus 1. So writing that out, I'm ignoring the bases since they're the same, would give us 8x equals 9x plus 3, and then solving that we get x equals negative 3. Alright, part D, this is the square root of x to the 5th power equals 32. So there's an invisible 2 right here. So we can write this as x to the 5 over 2. We can write it in fractional exponent form. Or you can just do the inverse of square root and the inverse of to the 5th power to get rid of those. If you write it as a fractional exponent, then you can raise both sides to the reciprocal of 5 over 2, which is 2/5, which cancels those out to 1, so x to the 1st power equals 32 to the 2/5 is the same as the 5th root of 32 squared. The 5th root of 32 is 2, 2 squared is 4. Alright, also on number 2, let's do this one. We don't have an equation, we just have an expression. Which expression is not equivalent to this? So if we rewrote this, or simplified it, we can reduce the 8 and the 20. So if we divide by 4, this becomes the square root of x to the 5th. You can also write that as x to the 5/2. So we're trying to figure out which of these expressions is not equivalent to these. 5 times 1/2 is 5 over 2, so that is equal. Negative 5 times 2 is negative 10. X to the negative 10th is not equal to this. Here we have a 2, an invisible 2 here. Square root of x to the 5th is the same as this. Here we have 1 over x to the negative 4/10. That is the same as the reciprocal of this, x over 1 to the positive 4/10, which is equal to x to the 2/5. This expression is not the same as what we started with.